Hello, today's lesson is lesson 4.2, multiply decimals and whole numbers. And our essential question is how can you use a model to multiply a whole number and a decimal? So we're still working on just being able to visually represent multiplying whole numbers by decimals. In our next couple lessons after this, we'll start, um, in a sense, multiplying the traditional way with decimals. All right, so we're going to use models today. And so you might want to have some colored pencils to color in the hundredths that we're multiplying by. So giant tortoises move very slowly. They can travel a distance of about 1700th mile in 1 hour. So 1700th mile per hour. So how far could a giant tortoise move if it travels at this same speed for 4 hours? So that's what we're asked to find, right? How far could it travel in 4 hours? So complete this statement. I need to find how many total miles are in how many groups of something. Well, we're counting by 4 hours, so that's my groups. So we have four groups. And in every group, there's going to be 1700. So what would that expression be? Well, four groups of 1700ths. So let's use the decimal model to answer this. So what does each small square in the decimal model represent? Well, remember, there are 100 squares in here. So each one is 1/100th. So they represent 1/100th, or we can just say 0.01. So we're going to shade a group of 17 squares to represent the distance a tortoise can move in 1 hour. That should be fairly straightforward. Let's do 17. I know each column has 10 rows because there's 10 rows of 10. So I'm going to shade in 7 of the next one. Okay, so now that's one group of 17. But it said shade four groups of 17. So use a different color to shade each additional group of 17 squares until you have four groups of 17 squares. All right, so that was my first group of 17. And here's 3, right? All right, so 3 and 10, we know that's the beat. That's 13, 14, 15, 16, 17. So we have two groups of 1700ths. So let's do one more group of 17. So we have 1, 2, 3, 4, 5, 6 left in this column. If we add 10 more to that, that would be 16. And we'd have to shade one more out of that column. So now we have three groups of 1700ths. And finally, let's finish up with one more group of 17 small squares. So we know we have 9 left in this column. And 9 and 8 is 17. So I'm going to shade 8 in the next one. All right. So now we have four groups of 17. 1, 2, 3, 4 groups of 17. So how many squares are shaded? 10, 20, 30, 40, 50, 60, and then 8 more, so 68 squares. Okay, so can the tortoise move 68 miles in 4 hours? No, because this represents one hole. So it's not even going one whole mile. So it's 68 hundredths. Because remember, each square was 1/100th. And we have 68 squares, so we have 68 hundredths. All right, let's look at page 172. Okay, so explain why you used only one decimal model to show the product. Well, the model shows hundredths, right? 100 hundredths, and the product was only 68 hundredths. So we have less than one whole. So only one whole model was needed. So since the model shows 100 hundredths, the product being only 68 hundredths means we only need one whole model. If we had over 100 hundredths, then we would need a second model or a second decimal model. Right, number two, explain how the product of four groups of 17 hundredths is similar to the product of four groups of 17. So one problem would look like that, and the other problem would look like this. Well, aren't those the same digits? Yeah. So, however, the decimal point would be in a different place. Okay. So, for instance, in the one that you're multiplying the decimal, it'd be 0.68. Four holes times 17 holes is 68. So remember that the decimal will be after the 8. Okay. So the decimal point is the only real difference. All right. So number three. So compare the product of 17 hundredths and 4 with each of the factors. Which number has the greatest value? Explain how this is different than multiplying two whole numbers. Well, so when we multiply 4 times 17 hundredths, the factor 4 actually has the greatest value. Okay, so the 4 actually has the greatest value in here. So how is that different than multiplying two whole numbers? In two whole numbers, the product is going to be the greatest value. Okay, so if we multiply two whole numbers, like 4 and 17, we know we'd get 68. Well, 68's larger than 17. 68 is larger than 4. So the product is the largest value in that multiplication problem. Here, when we multiply a decimal by a whole number, we get an answer that's in the hundredths as well, and 68 hundredths is less than one of the factors. So our value actually got smaller than the whole number. Our product got smaller. All right, so let's take some of those ideas, and now we can also draw quick pictures like we did in our last lesson to solve decimal problems with decimal multiplication problems. So first we're going to draw three groups of 46 hundredths. And remember that a square is equal to 1. One whole, right? Okay, so 46 hundredths. 1, 2, 3, 4, and 6 hundredths. All right, so we have three groups of 46 hundredths. 46 hundredths is 4 tenths and 6 hundredths. Okay, so now combine the hundredths and rename. So hundredths, we have 5, 10, 15, 16, 17, 18 hundredths. So I'll rename 10 hundredths as 1 tenth. So we're going to take 10 of the hundredths and rename them as 1/10. 1/10 as a tenth. Okay, so we're left with 5, 6, 7, 8 hundredths. Okay, now we're going to combine the tenths. And we have 4, 8, 12, 13 tenths. Well, we can regroup and rename 10 of those tenths. So we have 13 tenths. We're going to rename 10 tenths as 1 whole. So 4, 5, 6, 7, 8, 9, 10. And we're going to trade that for 1 square or 1 whole. So we have 1 whole and 3 tenths left. Okay, we have just these 3 tenths on the outside here. So we have 1, 3 tenths, and 8 hundredths. So 3 times 46 hundredths is 1 and 38 hundredths. Okay, let's look at 173. All right, so on 173, we see a decimal model, and I see 5 groups of 6 hundredths. 1, 2, 3, 4, 5. Well, if there's 10 in each column, that's 30. But each of these squares doesn't represent a whole, it represents 1/100th. So we have 30 hundredths. And that makes sense because 5 times 6 is 30. Okay, but we're multiplying by hundredths, not whole numbers. Both of these numbers are not whole numbers. So remember, when we multiply a whole number by a decimal less than 1, our product will be smaller than our factors. Smaller than one of the factors. Okay, the 5 is the largest value in this problem. In number 2, we need 2 groups of 38. All right, well, 10, 20, 30. That's 38 hundredths. Well, let's also shade another 38 hundredths. There's only 2 left there. So 12 22, 32, 33, 34, 35, 36, 37, 38. Okay, so two groups of 38 hundredths. What's our total? We have 10, 20, 30, 40, 50, 60, 72, 74, 76 small squares, or 76 hundredths. And that makes sense. Two groups of 38 is 76. But we're multiplying by hundredths. So 76 hundredths. Number three, we have four groups of 24 hundredths. So there's 10, 20, 24. We need another group of 24. So 2, 4, 6, 16, 18, 20, 22, 24. That's only two groups of 24 hundredths. We need four groups. So there's 2, 12, 22, 24. Now we need one more set of 24 hundredths. So we have 8, 18, 19, 20, 21, 22, 23, 24. All right, so how many do we have? Well, we only have 4 not shaded. If this is 100, that means there's 96. But we could always count by columns. 10, 20, 30, 40, 50, 60, 70, 80, 90, 92, 94, 96. So 96 hundredths. Okay. Seems pretty easy. Now, find the product and draw a quick picture. So we have 4 groups of 6 tenths. 1, 2, 3, 4, 5, 6. And we have 4 sets of those. All right. So how many tenths do we have? Well, 5, 10, 15, 20, 24 tenths. 24 tenths equals 2 and 4 tenths. So we can take 20 of the tenths, 5, 10. Every time you get 10 tenths, you get 1 whole. Okay. So if it's easier for you to do one at a time, do that. So this first set of 10 is 1 whole. This second group of 10 tenths is another whole. So there's 2 wholes here that we renamed from the 20 tenths. So what do we have? We have 2 ones and 4 tenths. 2 and 4 tenths. Number 5, we need 2 sets of 67 hundredths. Okay, that's one group of 67 hundredths. There's 2 groups of 67 hundredths. Combine the hundredths. 5, 10, 14 hundredths. Well, we can rename 10 of those hundredths as a tenth. That leaves us 4 hundredths. Okay, now how many tenths do we have? We have 5, 10, 11, 12, 13 tenths. Well, I can take 10 of those tenths and trade them for 1 whole. So I have 1 whole, 3 tenths, and 4 hundredths. So 1 and 34 hundredths. All right. Number 3, this time you need 3 sets of 62 hundredths. Okay. Combine the hundredths. There's 6 hundredths. You don't have to regroup. How about the tenths? Well, that's 5, that's 10. So we know that that's one whole. 5, 6, 7, 8. So I don't need to regroup the other ones. So that's 1 and 1, 2, 3, 4, 5, 6, 7, 8 tenths and 6 hundredths. 1 and 86 hundredths. Number 7, 4 and 32 hundredths. Okay, that's one set of 32 hundredths, two sets of 32 hundredths, three sets of 32 hundredths, four sets of 32 hundredths. Combine the hundredths. 2, 4, 6, 8. No need to regroup. Okay, now let's add our tenths. 3, 6, 9, 12 tenths. That means I can trade 10 of those 12 tenths for one whole. Sorry, I circled 11 actually. Okay, so there's 2 left outside. There was 12. So I took 10 and traded them for one whole, leaving me 2 tenths and the 8 hundredths. So 1, 2 tenths, 8 hundredths. 1.28. All right, so number 7. No, I mean number 8. Sorry. Describe how you solved number 7 using place value and renaming. Okay. Well, what'd we do? I drew 4 groups, right? What were in each of the groups? There was 4 groups of 3 tenths and 2 hundredths. 1, 2, 3, 4 groups, and in each group there was 3 tenths and 2 hundredths. We combined the hundredths. But we didn't have to regroup. And then I combined the tenths. What do we have to do when we got to the tenths? They were greater than 9. So we regrouped or renamed them. I renamed 10 of the tenths as 1, 1 and the remaining 2 tenths. So I renamed the 12 tenths as 1 whole and 2 tenths. So in words, explanation, that's just basically explaining what we did on that problem. Okay, number 9. Each day a bobcat drinks about 3 times as much water as a Canada goose drinks. How much water can a bobcat drink in one day? Okay. So we have the amount of water consumption by these animals. So a Canada goose drinks 24 hundredths liters per day. Well, that would be, right? 24 hundredths. That's the Canada goose. But the bobcat drinks 3 times as much in one day. So don't we need 3 sets of 24 hundredths? Okay, so let's do that. All right, so I've got 3 groups of 24 hundredths, 4, 8, 12 hundredths. So I want to regroup 10 of those hundredths as 1/10. Okay, so that leaves us 2 hundredths. And combine the tenths. 3, 5, 7. 7 tenths. So 72 hundredths liters of water. How about the number 10? The river otter drinks about 5 times as much water as a bald eagle in one day. How much water can a river otter drink in 3 days? Well, let's figure out how much the otter can drink in one day. So the bald eagle is 16 hundredths. So 10 and then 6 hundredths. 1, 2, 3, 4, 5, 6. Well, it said the otter drinks 5 times as much in one day. And then we also have to multiply by 3 because it's 3 days worth. So let's just figure out how much the otter drinks in one day. So we're going to need 5 sets of 16 hundredths. All right, so we have 5 groups of 16 hundredths. Combine the hundredths. 5, 10, 15, 20, 25, 26, 27, 28, 29, 30. So we have 30 sets of hundredths. So 30 hundredths. So I can take 10 of those hundredths and trade them for 1/10. I can take another 10 hundredths and trade them for another 1/10 or another tenth. Then we have 5, 6, 7, 8, 9, 10. So I can take all of those and trade them for a tenth. So we have no hundredths left. So how many tenths are there? 2, 3, 4, 5, 6, 7, 8 tenths. 8 tenths every day. So take 3 sets of 8 tenths. Okay. So how many tenths are there? 5, 10, 15, 18, 21, 24 tenths. Well, I know I can trade 10 tenths for 1 whole. 5, 8, there's another 10 that I'll trade for another whole. So we have 4 tenths left over and 2 wholes. So the otter can drink 2.4 liters in 3 days. Right, number 11, an animal shelter provides a bowl with 1 in 2,500 liters of water for 3 cats. About how much water will be left after the cats drink their average daily amount? About how much? All right, well, let's figure out how much the cats can drink in one day. So we have 3 cats, and the cats are drinking 15 hundredths in one day. So we need 3 sets of 15 hundredths. Let's combine the hundredths. 5, 10, 15 hundredths. So I can trade 1 of those 10 hundredths for a tenth, leaving me 5 hundredths. And we have 2, 3, 4 tenths. So we have 45 hundredths times 3. Not times 3, I'm sorry. We have 1 and 25 hundredths minus 45 hundredths. Well, we could, since it says about, we could round to the nearest tenth. We could round to the nearest whole number. We could use quarters. So that might be the easiest. So maybe it's just something like this. 1 minus 0. that would give us 1 liter. If we did 1.3 minus 0.5, that would leave us 8/10. If we rounded or used quarters, we'd have $1.25 minus 50. Well, if I think of it as monies, I have $1.25, which is 5 quarters, and 50 cents is 2 quarters. That would leave me 3 quarters, so 75. So it's going to be between 75 hundredths and 1 liter. All right, number 12. Yossi is shading the model to show 14 hundredths times 3. Describe what Yossi should shade to show the product. Then shade in the correct amount of boxes that will show the product of 14 hundredths times 3. Okay, so we're going to have 3 groups of 14 small squares. So let's shade those in. There's our first 14. Okay, there's 6 left here to color, and we need to shade 8 more. That's 14. And then we have 2 here. 10 more would be 12, and 2 in the top. So we have 10, 20, 30, 42 hundredths. So we have 42 small squares or 42 hundredths. All right, guys, so that's it for today. So I will see you soon, and we'll work on multiplying decimals and whole numbers some more.